Okay, question 10, question sort. Given an array of integers, sort the elements in the array in ascending order. The quicksort algorithm should be used to solve this problem. So the function is a quicksort. The input data is an int array that is not sorted, and the output data type is an int array, and that is sorted. And the assumption here is that we need to use the quicksort to sort this array in ascending order. And possible corner case is when the array is null or the length is 0, then we can just return the array. And at the same time, if the length is only 1, then we don't need to sort it either, so we can just return array 2. And the solution here is to use the quicksort. The idea is actually to randomly pick a pivot, and then we partition this array by moving all the elements less than the pivot in the left side, basically before the pivot, and put all the elements greater than the pivot in the right side after the pivot. And then we do the same thing for the elements in the left side and the element into the right side. So overall, we basically do it log n time if the pivot is selected well. But if unluckily, if we each time we happen to pick the smallest number or biggest number for the pivot, then we may need to do the n time. So if that happened, then the time complexity would be the n squared. But usually if we randomly select the pivot, then the average time complexity would be n log n. And the reason why it's n log n is because we basically call the function log n time, and then in each time we need to go through the partition, so we go through each element, so there's n log n. And then for the space complexity, is because we, worst case, we need to call the quicksort n times. So the space complexity can be on, but average case it should be log n if we pick the pivot well. And so now looking into the call. So first is the sanity check. First we check if the array is null or not, or if the length is less or equal to 1, then we can just return the array. And next is to call the function quicksort. We provide this array and then provide the range for the quicksort. In the beginning, the range will start from 0 to the biggest index. That'll be the array length minus 1. And at the end, we return array. And now in this quicksort, we write this function with 3 input, and the 3 input would be the in array and then also the index, the range left and the right, and the return type is void. So we have all the recursion setting here. First is the base case. So when the left greater or equal to right, that means there's no elements or only one element between the left and right, then we don't need to do quicksort anymore. Then we can just return. And the next is when there are more than one element, then we pick a number for the pivot. So we use the random to pick a number between left and the right, and then we find this pivot number, and then we move this pivot number to the right, and then we set out the left bound and right bound. So basically to go through all these numbers between the left bound and right bound, and if the number is less than the pivot, then we put it in the left side, and if not, then we put it in the right side. So this is the partition code. And then the next is that we finish the partition, then we move the index to the left bound, so that every number less than the pivot is in the left side, and bigger than the pivots are in the right side. And then we will continue to do the same thing for all the elements in the left side. So the range for the elements in the left would start from left, and then the left bound minus 1. And for the elements in the right side would start from left bound plus 1 and to the right. So, okay,